So in today's lesson, we are going to revisit the concept of solving quadratic equations. Here are two examples. Look at the example on the left first of all. Now, in our last session, we practiced solving equations using factorisation, and we're going to do the same thing again here. So we will start by setting up our brackets to find the two factors of x squared plus x minus 12. The brackets will both begin with x. Now we need to find a pair of numbers which will multiply to give us negative 12 and which will add to give us 1. We can't see it there because we wouldn't write it in, but we'll add it in 1x there. Now, which pair of numbers will do this? It's got to be a positive 4 and a negative 3. And you can always check by expanding your brackets and simplifying and collecting the like terms to see that you get x squared plus 1x minus 12 equals 0. We now create a pair of mini equations because the two brackets have a product of 0, which means either x plus 4 must equal 0, which then gives me x equals negative 4, or, as an alternative, x minus 3 must equal 0, which gives me x equals 3 as a root. So we have our pair of roots, x equals negative 4 and x equals 3, and we've solved this quadratic equation using the process of factorisation. Now, at the end of the last lesson, we had a look at an example a little like the question here, on the right-hand side. Now, what we discovered was that we were unable to factorise this, and if we tried, well, we weren't able to find a pair of numbers which multiplied together to give us positive 1 and which added together to give us positive 5. So our conclusion was that we could not solve this particular quadratic equation using the process of factorisation. We've got to use some other kind of process to see if we can solve this. Now, in a moment, we're going to introduce a special formula called the quadratic formula, which will allow us to solve any quadratic equation and which we can use in particular when we can't factorise a quadratic equation. Before we do this, however, we need to know how to identify the key parts of a quadratic equation. Now, a quadratic equation can be expressed in the form ax squared plus bx plus c equals 0, where a, b and c are numerical values which could be positive or negative. Now, it is absolutely vital that when you are given a quadratic equation, you must be able to identify the value of a, the value of b and the value of c for your quadratic equation. Let's take a look at a few examples. So here are our three examples, and in each case we're going to identify the value of a, the value of b and the value of c. Let's start with the first example. So the value of a is 2. We call this number the coefficient of x squared. Coefficient is another mathematical word for multiplier. 2 is the number by which we are multiplying x squared. It is the coefficient of x squared. Now, what is our value of b? It is the coefficient of x. It's equal to 7. In this case, a positive 7. And what is our value of c? It's this value here. It's equal to 5. Let's take a look at the second example. The coefficient of x squared is 6. So that's a, which is 6. The coefficient of x is negative 8, so b is equal to negative 8 and c is equal to positive 3. Now, in the last example, some of you might be thinking, well, there isn't a value of a, but there is. We can write in a 1 here. So we have 1x squared. So in this case, a is equal to 1. B is equal to 4, and C is equal to negative 7. C is the constant term at the end of the quadratic, which does not depend on x. So let's introduce the quadratic formula. The roots of a quadratic equation, which is written in the form ax squared plus bx plus c equals 0, where a, b and c are numerical values, can be found using the following formula. Let's write it down. X equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, you might be looking at this formula and thinking this looks extremely complex. You may not understand what the plus minus bit means just before the square root sign, but don't worry, we're going to look at applying this shortly, and it will all become very, very familiar and very simple once we start using it together. This formula is extremely important. You need to memorize it for your GCSE exam, and you must understand how to use it correctly, which is what we're going to look at shortly. So let's look at the first example, x squared plus 5x plus 6 equals 0. Now your first job is to identify your values of a, b and c. So if we write in a 1 here, we can say that a is equal to 1, b is clearly equal to 5, and c is clearly equal to 6. Now, let's substitute into the formula which I've written up on the top right-hand side. So we know that x is equal to minus b, which is negative 5, plus or minus, we'll put both in and then you'll explain what that is in a second, the square root, and then we need some brackets. Now, b squared. I think it's really useful to go back to this point here where you identify the value of b, and as well as writing down the value of b, write down the value of b squared. Remember, square numbers are always positive. That will become important later on. So b squared is equal to 25. So we have 25 minus 4 multiplied by a, which is 1, multiplied by c, which is 6. And this is all divided by 2 lots of a, which is 2 lots of 1. Really, we could just write 2 in the denominator there. Now, let's work out what we've got here. So minus 5 plus or minus, we've still got that combination there, the square root of, well, hopefully you can see that underneath the square root sign we have 25 take away 4 times 1 times 6, which is 24, all over 2, which is minus 5 plus or minus the square root of 1 over 2. Now, what is the square root of 1? Well, it's 1. So this becomes minus 5 plus or minus 1 over 2. Now, how do you deal, and this is the big question, with this plus or minus? Well, the answer is we do it separately. We look at what happens if we use the positive root and what happens if we take the negative. So if we follow the positive version, we have negative 5 plus 1 all divided by 2, which gives us a value of negative 2 as an answer for x. Now, if we follow the negative direction, x is equal to negative 5 minus 1 over 2, which gives us an answer of negative 3. And remember, quadratic equations have 2 roots typically. So we have x equals negative 2 and we have x equals negative 3. Now that's interesting. Both these answers work out to be integer values. And that's because I chose as this first example a quadratic which actually could have been factorised. So if you go back to the original question, I could have factorised this, x plus 2, x plus 3 equals 0, which then gives me x plus 2 equals 0, or x plus 3 equals 0, which then gives me answers of x equals -2 or x equals -3. So that's really interesting, because we could have solved this quadratic equation by factorising to get two very easy answers of -2 and -3 using a very easy process. Now, the quadratic formula process looks a lot more complex. It does give us the same answer, so you might be asking yourself, well, why do we use the quadratic formula? When do we use it? Well, there are many, many quadratics that do not factorise. And in these instances, we need alternative ways of solving them if we can. And the quadratic formula will allow us to solve a quadratic equation that cannot be factorised. Now, factorisation is still an extremely powerful process, and you should always try and factorise first. If you cannot solve your quadratic equation using factorisation, that's when you start to think of other methods, such as using the quadratic formula. Let's look at another question. We're going to solve the quadratic equation x squared plus 4x plus 1 equals 0. Now, this is an example of a quadratic equation that will not factorise. We cannot find numbers that multiply together to give us 1 and add together to give us 4 easily. There are no integer values that do this. So let's start the steps of the formula. First job, we need to identify a, b and c and the value of b squared. So a is equal to 1x squared again. B is equal to 4. And write down b squared as well. It's equal to 16. Do not miss out that step. It will come very much in use later on when we look at some more complex examples. And c is equal to 1 as well. Now, let's substitute into the formula, which I've copied and pasted on the top right-hand corner for you for visibility. So x is equal to minus b, which is -4, plus or minus the square root of b squared, which is 16. I'm not even going to write 4 squared, I'm going to write 16 in straight away, much easier. Minus 4 multiplied by a, which is 1, multiplied by c, which is also 1. And this is all divided by 2 lots of a, which I'm just going to write in as 2 this time. Much easier. Now let's simplify. So we have -4 plus or minus the square root of, well, that's 16 take away 4 in the bracket underneath the root, all over 2, which is -4 plus or minus root 12 over 2. Now, this is interesting because we have two options here. We might be asked to give our answer in surd format, and we might be asked to give our answer as a decimal value. We're going to look at the answer in decimal form first of all, and then we'll come back to writing this in a surd format. It's a good opportunity to practice our surds. So remember, we've got one version of the answer where we would have -4 plus root 12 all over 2. So we're taking the positive version here. And then we would have another version of the answer, which is x equals -4 minus root 12 all over 2. Now, input this into your calculator and let's see what we get. So for this answer, we get a value of -0.2679, which is -0.268 to 3 significant figures. And for this value over here, we get an answer of -3.732, which is -3.73 to 3SF. So we can find decimal values and then round them. But remember, sometimes we might be asked to present our answers in surd form, and I'm going to do that in this little space over here. So we're going to simplify root 12. So we have -4 plus or minus, and then let's see if we can do that over here. So root 12 is equal to root 4 multiplied by root 3, which is 2 root 3. So -4 plus or minus 2 root 3 all divided by 2. And then we can simplify this a little bit further because, as you will see, this can be divided by 2, and this can also be divided by 2. So this leaves us with -2 plus or minus √3 as our final answer in surd form. And you are allowed to present both your answers together using that plus or minus format. If you want to write the answers out separately as two separate answers, you could say x equals -2 plus √3 or x equals -2 minus √3. So you give the answers as two separate values, but it is perfectly acceptable in the context of a question to give the two answers together using the plus-minus format, unless you're asked to do otherwise. So let's have a look at a third example here. As always, we're going to identify A, B and C to begin with. So again, we have A is equal to 1, B is equal to 6, and B squared is equal to 36. Then C is equal to -2. Let's immediately input these values into the quadratic formula on the top right over there. So x is equal to -b, which is -6, plus or minus the square root of, brackets, 36 minus 4 multiplied by 1, which is A, multiplied by C, which is -2. All over 2 lots of A, which is again just 2. Now, the bit where people quite often make mistakes is when they're evaluating this part here underneath the square root sign. Now, if you input this directly into your calculator, the part in the bracket, you will of course just get the correct answer as long as you're careful and input exactly what you can see here. If we work it out without a calculator, we're doing this calculation here, which is 36, and then there are lots of different ways of thinking about this. If I work out this part here first of all, that's 4 multiplied by 1, which is 4, multiplied by -2, which is -8. But don't forget that there's a negative here as well. 36 take away -8, which of course gives you, under the square root sign, a value of 44. You can always check that with a calculator. Usually when you're solving quadratic equations using the quadratic formula, you will be using a calculator to do this. So this is -6 plus or minus the square root of 44, all divided by 2. Now again, we can give our answers in surd form or decimal form. We're going to do both of those. So first of all, we're going to write them out. X equals -6 plus √44 all over 2. And then as the other form, x equals -6 minus √44 all over 2. And I'd like you to input these into your calculator separately and check that you get the correct answer. So for the first calculation, we get a value of 0.3166 ... which we can round to 317 to 3 significant figures. And for the second calculation, we get x is equal to -6.3166, which rounds to -6.32 to 3 significant figures. Make sure you've got both those answers correct. If you haven't, you're making a calculator error. Now, sometimes this happens because people don't listen to instructions and they try and type in the whole quadratic formula into their calculator in one step, instead of working it through by steps and getting to this version here, which they can then write down and then substitute into the calculator. Let's have a look at doing the same calculation in surd form. So x is equal to -6 plus or minus the square root of 44 all divided by 2. So what I'm going to do is look at the root of 44 and break it down. It's √4 multiplied by √11, which is 2 √11. So I can replace √44 with 2 √11. Now, the 6 and the 2 √11 can both be divided by 2, which gives me -3 plus or minus √11. So again, if I wanted to, I could write out the two separate answers, or I could, unless I'm told otherwise, leave them together like this in surd form. Let's take a look at question 4. which again is a little bit more complex. So first of all, identify the value of a, b and c and b squared. So a is equal to 1 again. B is equal to, this time, -5. So think carefully about that. Now, this step here is where a lot of people make silly mistakes. B squared is the square of b, which means it is the square of -5, which means it is 25. It is not -25. And sometimes people input that into their calculator without any brackets and get an answer of -25. Or they just don't stop and think and remember that square numbers have to be positive. I want you to make sure you've written a very clear note to yourself that says b squared will always be positive. And remember that because it will hopefully stop you from making silly mistakes when you're using the quadratic formula. And the last value, c, is equal to -3. Now here's the formula on the top right again to help you work this out. X equals minus b. Well, what's minus b? If b is -5, then negative b is going to equal 5. Be careful. You've got to really watch out for that in questions which involve negative numbers and negative values for b. So that's a negative b part, plus or minus the square root of bracket. Now b squared is 25. See how much simpler this is than writing minus b all squared or -5 all squared where people make silly mistakes. Minus 4 multiplied by a, which is 1, multiplied by c, which is -3. We're going to be really careful here when we work this out. And this is all divided by 2 lots of a, which again is 2. So let's again evaluate this part here that is underneath the square root sign. So the 25 minus 4 times 1 times -3, this bracket here. So that is equal to 25 take away, and then again I'm going to work out this part here. 4 times 1 times -3, which is -12. So it's 25 minus -12, which is 37. So the part underneath the square root sign is 37. So we have 5 plus or minus root 37 all over 2. Now, because root 37 doesn't break down into a simpler surd, we're simply going to evaluate this using the calculator. So x equals 5 plus root 37 over 2 as one answer, and then as our other answer, x equals 5 minus root 37 all over 2. Could you please make sure you input these into your calculator separately and check you get the correct answers and then round them to 3 significant figures. So here are my answers. My first one is 5.5413, which simplifies to 5.54 to 3SF. And my second answer is minus 0.5413, which simplifies to negative 0.541 to 3SF. And I've chosen this example specifically to ensure that you look at an example where the b value is a negative number. So please make sure you've worked through this really carefully and you've understood how this question has worked. Let's have a look at the final example we're going to work on today. So this time, notice we have a equals 2, a little bit different. B, again, equals -3 in this case, so it's negative again. So b squared is equal to -3 squared, which is 9. And c equals -7. Substituting into the formula, which you can see in the top right-hand corner to help you, x equals minus b. What is minus b equal to? It's equal to 3 because, remember, b was a negative value, so negative b is equal to -3, which is equal to 3. Be very, very careful with negatives. Plus or minus the square root of, now again, b squared, remember, we wrote down all square numbers are positive. B squared will always be positive, so that's a 9, minus 4 multiplied by a, which is 2, multiplied by c, which is negative 7. And this is all divided by 2 lots of a, which is indeed 4 this time. So be careful, 2 lots of a, work it out properly. So what is the part underneath the square root sign equal to? So our 9 minus 4 multiplied by 2 multiplied by negative 7. You can just input this straight away into your calculator to see what you get from that calculation, and it will give you the right answer if you input it in correctly. We'll work it out again manually. So that's 9 take away. 4 times 2 is 8. 8 multiplied by negative 7 is negative 56. So it's 9 take away negative 56, which comes to a value of 65. So we have 3 plus or minus root 65, all divided by 4. Root 65 isn't a third that simplifies in a particularly neat format, so we will work out the two roots separately as decimal values. So 3 plus root 65 all over 4 is one value of x, and the other value is 3 minus root 65 all over 4. Input them separately into your calculator and check that you get the correct answers. So you should find that you get an answer of 2.7655 ... or 2.77 to 3 significant figures, and your other answer is negative 1.2655 ... or negative 1.27 to 3 significant figures. So we're going to finish off with a summary of some of the key points that you need to remember when you're using the quadratic formula to solve a quadratic equation. Now, the first point is that if you're trying to solve your quadratic equation, it should always be rearranged into the format ax squared plus bx plus c equals 0 first, where a, b and c are numerical values which could be positive or which could be negative. Now, the second key point is you should always try and factorise first if you can, because it's a much quicker way of solving quadratic equations usually. If you can't factorise, then using the quadratic formula is a good second step. Now, you must memorise the quadratic formula. You are expected to know it from memory and use it in GCSE exams. You will not be given this formula in a GCSE exam. Now, always start by identifying the values of a, b, c and also b squared, and remember that b squared is always going to be a positive value. Be very careful if b is a negative number, because then negative b will be a positive number, like in two of the examples that we've done today. Now, although you may end up using the quadratic formula with a calculator, you may also have to demonstrate that you can use this in a non-calculator situation as well. So it's important that in all of the examples that we've done, you've worked through each question in the format that I've used, and that you set your working out very clearly and very carefully. If you just practice these questions by shoving the numbers into your calculator, you are missing vital stages of the calculation and you are not preparing yourself appropriately for questions involving the quadratic formula. So follow the structure of the guided examples very, very clearly. Make sure when you do some practice in the next lesson that you use this structure, this format, very carefully.